All right, now we're gonna look at the volume of cones. So our big idea for today, as you can see, is how to find the volume of cone. The volume represented by the variable V, capital V, of a cone is 1/3 the product of the area of the base and the height of the cone. Okay, so hopefully by now, class, you are able to see some patterns, like I said before. Our formula is very similar to that of a pyramid. The difference is that our base is not a square or a rectangle or a triangle, but with a cone, our base is a circle always. That's what a cone is. Okay, so you have to again know what the area of the base is, what the formula is. So the area of this base again is a circle, guys. So our formula is going to equal pi times the radius squared. Okay, that's what we're going to be inputting for the area of the base. Our base is a circle. Okay, our base is a circle. And then again, we're going to look at the height of the overall object. In this case, it's a cone, so the height of the cone is what we're going to look at when we input it into here. Okay, now let's take a look at example 1. We're going to literally find the volume of this cone. So I'm going to write my answer. Or excuse me, not my answer, I will write the answer, but I'm going to write the formula. 1/3 times the area of the base times the height. Okay, so I have to understand, what do I need to know to input this into this formula to get my answer? Well, I need to know the radius of my base. This is a circle. This here is not my radius. This, in fact, is my diameter. Okay, this is the diameter of the base, which is a circle. That means our radius is half of that. Half of 4 is 2. Remember, radius is from the center to one point of the circle, or one edge of the circle. So this is 2. Okay, diameter is 4. Half of that is 2, which is our radius. Okay, this here, the 6 meters, this represents the height of our cone. Okay, height of the cone. Okay, and that is what we need in order to find our volume. Okay, so let's input this information here. 1/3 times the area of my base. Okay, so our base is a circle. This would be pi times our radius, which is 2, and I'm going to square it. And then I'm going to multiply by the height, which is 6. Oh, and I keep not doing the right colors. That's okay. Okay, so I'm going to multiply this out, simplify. I'm going to leave the 1/3 there. I'm going to look at what's inside the parentheses, and I see my exponent. 2 squared means 2 times itself, or 2 times 2, which is 4. So then I'm going to have 4 pi times 6. Oops, forgot that parenthesis there. 4 times 6 is 24. So I'm going to get 1/3 times 24. 24 pi. Okay, this is just one way you can do it. I'm just doing it step by step. 24 pi. And I know 24 times 1/3 is the same thing as 24 divided by 3. You can put that in a calculator if you don't know that on top of your head. But 24 divided by 3 is going to give me 8, and I'm left with pi. 8 pi. So again, class, if you remember me talking about this, sometimes they want you to leave it like this. This is going to be our exact answer because it is in terms of pi. Pi goes on and on and on, and this symbol represents what pi is. A decimal that keeps going on and on and on. 3.14159 and so on. Okay. So what I put into my calculator is going to be 8 times 3.14. Okay, so I'm going to show you guys what that looks like with my calculator this time. Let me grab that. So I'm going to get 8 times 3.14. It's going to give me 25.12. Okay, so volume is about 25.12, but they asked me to round to the nearest tenth, which is going to be about 25.1. The 2 is under 5, tells me to keep that the same. 25.1 meters cubed. Again, we are dealing with volume, so our units have to be cubed. Okay? all I did, class, was take what I was given and input it into my formula correctly, simplified, and solve for what I needed. I simplified and I got 25.1 meters cubed when I rounded to the nearest tenth. All right, now let's take a look at example 2. I hope you guys can see that. Let me move this. Okay. Example 2, instead of finding the volume, we're going to find the height of our cone. We're already given our volume, and again, we're going to round our answer to the nearest tenth. I'm going to write the formula because right now we're still learning it, so we got to make sure that we have it written down correctly. We have 1/3 times the area of our base. Remember, big B is area of the base times our height. Our base, again, is a circle, so I have to know that it's going to be pi times the radius squared. The 9 feet given right here, this is exactly what we want. This is the radius of our base. Okay, we need that. That's our radius. This is our volume. That's exactly what we're looking for as well. That's really helpful to have. So let's use that information and substitute it in for volume. We already know what volume is. Our volume is going to be 956 feet cubed, and that's going to equal 1/3 times the area of our base. And again, our base is a circle, so it's going to be pi times our radius, which is 9, and we're going to square that, pi r squared, times our height. We're looking for h. We're going to be solving for h. Okay, so now I'm just going to simplify. I get 956. I didn't do anything there. I left it as is. I'm going to multiply by, use the exponent in here, which is 9 squared, which means I'm going to multiply 9 by itself, which is 9 times 9. And 9 times 9 is going to give me 81, and I'm left with pi. 81 pi. And multiply by h. Okay? Again, 81 times 1/3 is the same thing as 81 divided by 3. So I'm going to show you. Here's my calculator. 81 divided by 3 is going to give me 27. So I get 956 equals 27 pi times h. Okay, so this is where I was talking to you, or what I was talking to you about earlier previously in class, was I can do it step by step, or I can do it all in one step. I'm going to solve for h by dividing by 27 pi on both sides. I'm going to do both 27 and pi because I know I'm going to be doing that if I do it step by step anyways. 27 divided by 27 is 1. That cancels. Pi divided by pi, that's also 1. That cancels. So I'm left with h here. It's what I want. But whatever I do to one side, I have to do to the other side, and that's why I'm dividing by 27 pi. Okay, when I look at this class, I look at 956 and 27. 956 divided by 27 is going to be that fraction, or that decimal, and I don't really like that, so I'm just going to input it into my calculator. This is what I do when I do that. I'm going to take 956 divided by, and notice how I'm going to put it in parentheses, my denominator, 27 times 3.14, end parentheses, that equals that. Okay, so I have here, I'm going to show you what I wrote. 956 divided by 27 times 3.14. I had to put this in parentheses, otherwise my calculator is going to do order of operations. That's what it's programmed to do. And if you put it 956 divided by 27 times 3.14 straight like that, you're not going to get your answer. You got to make sure that this part is in parentheses. It calculates this. So this divided by whatever the product of this is. Okay, so I'm going to get my height is about, 11 point. They want me to round to the nearest tenth. This is a 7, so it's telling me I need to go up. Oh, no. Sorry, class. Technical errors. Oh, goodness. Thank you guys for bearing with me. I'm not going to bother redoing this because I know it's going to waste too much time. So my height is about 11.3 feet. Okay, not cube because I'm just looking at feet here. So that is the answer. okay? Alright guys, and we just found the height of this cone. Okay, I'm going to try to fix this while I turn it over. I apologize again, I don't know why this keeps happening, but this was supposed to be on the other side, and this is the part where I'm going to have you guys practice that and send me your work and your answers. Okay, so I'm going to flip this over. Oh goodness, there's some drama for you guys, I guess, for the day. Excitement. Okay, so let me hold that there, hope that stays. Volume or height of the cone is what you're going to be solving for. This one you're going to be solving for the volume, and this one you're going to be solving for the height. So this is from example 1, this one is from example 2. And because I want to make sure you guys know if you're doing it right or not, I'm going to give you the answers. The answer to the first one, finding the volume of this is going to be 180 pi, which is about 565.5 centimeters cubed. Okay, that's the answer to this one. And the answer to the height of this is going to be 96 divided by pi, okay, which is about 30.6 yards. Okay, so that's the answer to this one. Just so you have the formula in front of you, 1/3 times the area of the base times the height. Volume equals 1/3 times the area of the base times the height. Okay, so just make sure you have that information down, input what you're given, and hopefully you guys get these answers here. And again, I want to see your work posted on your Google Slides. All right, let's do our last example, hopefully before we have any more technological issues. Example 3 is going to be a real life application problem, and it says you must answer a trivia question before the sand in the timer falls to the bottom. So here's the sand. You got to answer the question before all the sand is in the bottom here. The sand falls at a rate of 50 cubic millimeters per second. So in other words, 50 millimeters cubed per second. Okay, how much time do you have to answer the question? So in order to correctly answer this question, we're going to use the formula for volume of a cone to find the volume of the sand in the timer. Because if you notice, this is a cone and this is a cone. Okay, so our formula is 1/3 times the area of the base times the height. Okay, so you need to memorize that formula. I have here the diameter of this base here, which is 10 millimeters. And that's what I'm going to be focusing on, not this whole length here, because we're looking at the sand specifically. Okay, so this here, let me label it for you. This here is our radius of our base, okay, and this is here our height, okay, our height of our cone. Okay, so I'm going to input that. I get the volume. We're trying to find the volume of the sand here. Volume is 1/3 times the area of my base. Well, my base is a circle, so it's going to be pi times the radius, which is 10 squared. Okay, and then we're going to multiply by our height, which is 24 millimeters. So I put 24 here. Okay. So we're just going to simplify now. I'm going to do what's in the parentheses first. I'm going to do 10 squared. 10 squared is 100. So I really have 100 pi times 24. Now, because this is how my brain works, I see the 1/3 and I see the 24, and I know I can multiply those two out. 1/3 times 24 is the same thing as 24 divided by 3. So what I really have is 8 times 100 pi. Okay, 100 times 8 is obviously 800 pi. Okay, and that is our exact answer. If I were to round it out, I would do, I guess I should do about 800 times 3.14. And I'll show you what that is here. 800 times 3.14 is going to be 2,512. So this is about 2,512. Oh, kind of surprised. Sorry, 800 times 3.14. Is that, oh, you know what they did? They did 800 times 3.141. Oops. 3.14159. That's probably what they did. Yeah, so they got about 2,513. No big deal. But I'm gonna write that there for you guys. They did the exact answer, or exact pi. Again, no big deal. I would not dock you if you did this, but just so it matches what's in your textbook. They actually multiplied by all of pi, but just to get the answer, I did 3.14159. That should be enough digits, and then you'll get the answer that they get. About 2,513 is the answer. The volume here, millimeters cubed. Okay, so millimeters cubed. All right. But we're not done yet because we want to know how much time do I have to answer the question, and not necessarily what the volume was. So it says the volume of the sand is about 2,513 millimeters cubed. Okay, we just found that right here. Now it says that to find the amount of time you have to answer the question, we're going to multiply the volume by the rate at which the sand falls. Okay, by the rate at which the sand falls. So I'm going to take my answer, 2,513 millimeters cubed, okay, times the rate. Well, in this case, the rate is going to be a proportion. It gives us the rate, if you look at the question here, 50 cubic millimeters, and that's going to be 1 second per second. So every second it falls 50 millimeters cubed. Okay, now some of you are going to say, well, why do I need to switch it like that? And the reason is because I want to be able to cancel out my units here. When I have something over itself, it cancels, and that's what I'm trying to do here. So really, I could put this over 1. We don't, just to keep that as a whole number here. It's kind of neat. This and this cancels. And so I'm left with 2,513 seconds divided by 50. The units have canceled here, and that's what I want. I want seconds on top here. And let me do that for you all. I have 2,513 divided by 50. It's going to give me about, or it equals, I should say, 50.26, okay, seconds. All right. So in other words, I know this is a really complicated question. I don't expect you to necessarily know how to do that right off the bat, which is why I don't have an example problem for you to do with this. I want you to know you have about 50 seconds to answer the question. Okay, so what makes this question so difficult is understanding that you have to find, one, the volume of the sand, and then use the rate in order to find how much time you have to answer it. This is the rate at which the sand is falling, and this is how much sand that we have. So if we multiply them out, we're able to find out how much time it's going to take. So here's the volume of the sand multiplied by our rate, and we switch the numbers. So 50 is now on the bottom so that our units cancel, and we're not left with millimeters cubed anymore. We're left with just seconds on top. So when I have them opposite sides of the bar here, this is going to cancel because it's 1. So that cancels, and I'm left with seconds. So I just multiply straight across. 2,513 times 1, and 1 times 50. I get 2,513 divided by 50, which gives me this answer here. Okay, and I realize that's really hard to see. Okay? Again, class, please make sure you are putting your practice problems on your Google Slides.